Okay, I want to look at this question, section 1.7, number 73, where you're solving an absolute value inequality. Whenever you have an inequality involving absolute value, if the absolute value is isolated on one side of the inequality symbol and a positive number is on the other side of the inequality symbol, your first step is to rewrite the equation without absolute values. So, or the inequality without absolute values. So the first thing I need to do is to rewrite this as an equivalent statement that doesn't have absolute value bars. So for the absolute value of 3x minus 3 to be greater than 9, 3x minus 3 needs to be less than negative 9, or 3x minus 3 needs to be greater than 9. So this compound statement is equivalent to the absolute value statement. And so notice for the absolute value of a number to be bigger than positive 9, or an expression, that expression either is to the left of negative 9 or to the right of positive 9. And so we're going to solve these two inequalities. So that would be our step at this point. Okay, so let's take a look. So we want to isolate x on the left side of the inequality in each case. So here on the left inequality, that means I'm going to be adding 3 to both sides. And that's also what I need to do to the inequality on the right. So I wind up with 3x less than negative 6, or 3x greater than 12. So notice these are not equations. These are inequalities. In order to isolate x in both inequalities, I need to divide by 3. So as long as I'm dividing by a positive number, the inequality symbol is going to remain as is. Its direction is not going to change. If I multiply or divide by a negative number, I would have to rewrite this in a separate step and reverse the direction of the inequality. So x is less than negative 2, or x is greater than 4. So notice this is not saying x equals negative 2, and it's not saying x equals 4. So either x is a number smaller than negative 2, which I can write in interval notation as the interval negative infinity, comma, negative 2, parenthesis, meaning the negative 2 is not included. I write a union symbol in place of the word or, and then to write in interval notation the inequality x bigger than 4, parenthesis 4, which means 4 is not part of the solution set, comma, infinity. So I can pick any number to the left of negative 2 or any number to the right of 4 on the number line, and my inequality will be true. So notice this actually is my solution set. All right, and the thing to note here is it would not be correct, it would be absolutely incorrect to say that x is negative 2 or that x is 4. Notice that we have an infinite collection of numbers that make the inequality true. These are two disconnected sets of numbers. neither set contains negative 2 or 4. Okay, in this problem, the quadratic formula was used to solve the equation x squared plus 13x plus 8 equals 0. And the correct solution set is shown here. And I just want to point out the incorrect answer that was entered. Notice it is, the difference between these two is in the incorrect answer that I'm pointing to here, negative 13 plus the square root of 137 divided by 2, and then negative 13 minus the square root of 137 divided by 2, is incorrect. And when you look at the correct answer, the difference would be that this correct answer could be written as minus 6.5 plus the square root of 137 over 2 minus 6.5 minus the square root of 137 over 2. So in other words, you're off by a value of negative 6.5 when you write it in this format, because you're not dividing, you're adding negative 13 to this irrational quantity as opposed to adding negative 6.5 to these irrational quantities. So for this type of answer, obviously the answer is incorrect. So you want to be careful about this type of formatting. Using the quadratic formula, it's important that this numerator include not only the negative b, but also the addition and subtraction of the square root of b squared minus 4ac. So you just want to be careful about that in submitting your answers.